Okay, guys. So as long as we get back to OCC after spring break, this is going to be our probably the last video lecture. So this will, if you happen to check out this video before test three, this will not be on test three. So test four is chapter 9, and it's just one chapter all by itself, muscle tissue. Okay, so we're just going to do the beginning of the chapter, which is kind of just basic and kind of review and background stuff like this. This we already know. So recap 3 types of muscle tissue. So remember, what was that on test 2? That was that question. What are the 3 types of muscle tissue? Which has striations and which has voluntary control? Hey, you know what? On test 4, I cut and paste exactly the same question. So you guys all got it right on test 2. Get it all right again on test 4. So remember, skeletal muscle, it's usually, not always, attached to the skeleton, so that's why I get that name. But one thing you want to highlight here, remember, this is voluntary. So skeletal muscle is voluntary. And remember, it's striated also. Now here, guys, I'll leave it up to you, but if you don't remember what striated means, remember it means striped. So remember the stripes or the striation comes from the microscopic appearance of the muscle fibers. So you might remember back in the day we checked out a picture. Oop, nope, not that, and not that, but that. So here we got some skeletal muscle fibers, and so each one of the, by the way, a muscle fiber is a muscle cell. I'm getting ahead of myself a little bit. So these are skeletal muscle cells. Each one of these long red stripes. And note, while we got it up here, so they're not at all shaped like a typical cell. They're really, really long. They've got multiple nuclei, and here's the striations. You see this like kind of cross-hatching pattern that they've got. All right, so let's go back to here. What are the striations composed of? Now, we're going to do the details on this later on. So for now, this is just by way of review. Or for the point of review, I guess I should say. Paste. It comes from the cell cytoskeleton, how the cytoskeleton's set up. If you guys don't remember the cytoskeleton from chapter 3, remember the cell skeleton. It's a dense network of proteins, and all your cells have it, and it helps support them and lets them move and stuff like that. And it's really modified in these muscle cells. All right, we'll do that later. But go ahead and write cytoskeleton right there. Hey, and here's what I just said a little while ago. Note on skeletal muscle cell shape and name. So they don't look like generic cells, and we saw a flat, it's a 2-dimensional picture, but if so it looks like they're like stripes or something, like big. I don't know, I shouldn't say stripes. It looks like they're kind of like big, long, like ribbons or something like that. They're really cylindrical, so they're very long cylindrical cells. And at first, I was calling those muscle fibers before I told you what that meant, but add this on here. So they're called muscle fibers. Fibers like a thread, it's kind of long. So this chapter, and you heard a bunch. Every time you hear muscle fiber, this chapter, it means muscle cell. Oh, here, let me move this over a little bit. There we go. All right. So skeletal muscle, voluntary, striated. Cardiac muscle, remember this is involuntary. Oops, involuntary. And also striped. And remember, the only place you get cardiac muscle is, where cardiac muscle is. It tells you its name. It's in the heart. All right, smooth muscle. Remember, it's called smooth because the cells do not have stripes. And this is involuntary. Involuntary. No voluntary control and no stripes. So here, though, the name tells you what it looks like under the microscope. It doesn't tell you where it is. So you guys remember where you get smooth muscle? Probably a good thing to write here, and this is what we did back in chapter 2, was we said hollow organs. As a rule of thumb, if you got a hollow organ, it's probably got some smooth muscle in the wall, like the intestines, or the stomach and the digestive system, the ureters and the urinary bladder and the urinary system, blood vessels, bronchial tubes, and lung. So here, for locations, just write down hollow organs, and then put example, and write down just one of those things I just said, intestines or ureters, or just whatever you want. All right, functions of muscle. The number one function of muscle is to produce movement. And you guys don't have to add anything to that. Gross body movements like moving your arms around, propelling stuff through the body, like, cardiac muscle pumps the blood through us, and so on and so forth. Okay, is that good enough there? All right, stabilization of joints. Back in joint chapter, muscles got a nod as one of a big factor that contributes to joint strength. So squeeze this in here. I think we mentioned this one back in the day. I know you don't have a lot of room there, but so example for the shoulder, you guys have heard we haven't done the muscles yet, and we're going to do a couple of them when we do lab, but you've heard of the rotator cuff muscles. They're these 4 muscles that surround the shoulder joint, and they're like probably the most important factor for stabilization of the shoulder joint. I mean, they produce movement at the joint, but they're also very important for stabilization. Maintenance of posture. It says, well, you know, I said the point of muscle is to produce movement. I want to get rid of that. All right, never mind. I said the point of muscle is to produce movement, but just because movement isn't occurring doesn't mean that muscle is not contracting. You know, like to hold you up against gravity and, you know, stuff like that. You don't have to add anything to that, though. That's good enough. All right, heat generation. So skeletal muscles generates a substantial amount of heat. It's usually a kind of a side effect, but it says it can be used for thermal regulation. Again, you guys don't have to add too much to that, but down here it says example. Like if you want, you know, if you're cold, you shiver, which is skeletal muscle is voluntary, but against that rule of thumb, involuntarily you can get shivering, so you get those rapid muscle contractions, and the point there is to, you know, generate the byproduct, the heat is what you want. You know, how it kind of warm you up a little bit. All right, skeletal muscle. 3/4 of the chapter we spend on skeletal muscle. So it says name skeletal muscles of the body, like the biceps brachii or any other muscle you've heard of before, the deltoid or the gluteus maximus, kind of a famous one. It says they're really organs like your heart's an organ. Because your heart's an organ, because it's got, remember what and if you don't remember, this might be worth writing down, guys. An organ, a quick definition, is a group of tissues with a common function. So in the heart, you've got cardiac muscle, but there's also nervous tissue, nerves and stuff that innervate it. There's connective tissue wrappers, and it's got the function of, you know, pumping blood, so it's an organ. But your biceps brachii is the same thing. It's skeletal muscle, but it's also got nerves and connective tissue wrappers and stuff like that. So it's an organ just like your heart is, histologically anyway, I guess. But there. Oh wait, I didn't mean to put that in. We already did that. Sorry, my bad. So here for other tissue types present, you've got, here I'll just type it in since I messed it up. Nervous tissue. Oh, it's small font if you guys can't read that. Nervous tissue. And there's also connective tissue. All right. So connective tissue wrapper. So here's the connective tissue part we were just talking about. You guys want to look for a picture in your book. If it's not exactly this, it's pretty dang close to it. So you've got some kind of a generic sort of muscle plugged into a bone. There's this tendon right there. We'll talk about that here in a minute. But it shows you the wrapper system. So you take a whole muscle, like whatever this is, and on the outside of it you put a dense outer wrapper, and it's called the epimysium. Epi means above because it's on the outer surface. And guys, anytime you see mice, or especially myo, we'll see my and myo a bunch this chapter. It means muscle. So it means above the muscle. All right, so that's a tough outer covering. And then if you look on the inside, skeletal muscles are composed of these little bundles that are called fascicles. So like when you're eating like pot roast or something and it comes apart, it's like nice and tender, and it'll come apart in those strips. Those strips are the fascicles of that muscle. So, and here they're pulling one pot roast strip out. Does it say here? But anyway, all right, yeah, just it doesn't say it, but take my word for it. That's one pot roast strip coming out. And then each pot roast strip, each fascicle, I'm going to say from now on, not pot roast strip, each fascicle has got a wrapper around it called a perimysium. But if you look at the fascicles, it itself is made of a bunch of little strips. Now, those are the muscle fibers. Remember, anytime you see that muscle fiber, that's a muscle cell. And here you're pulling one cell out. Each muscle cell, then, has got a wrapper on it called an endomysium, an inside muscle wrapper. And this we'll get into later on after we come back from break. But even if you look inside of a muscle cell, there's even a bunch of little cylinder things in there. So the cells are packed full of cylinders. You take a bunch of cylindrical cells and pack them together into fascicles. You take a bunch of cylindrical fascicles and pack them together into the muscle cell. But, so, wrappers and wrappers and wrappers. You got an endomysium that wraps the muscle cells, a perimysium that wraps the fascicles, and an epimysium that wraps the whole dang thing. And then here is what we just said. All right, so connective tissue wrapper. All right, endomysium. I'm going kind of the opposite way, I guess, the way we did on the picture. But loose connective tissue wraps the individual muscle fibers. I don't think there's anything else you guys need to put there. Then many wrap fascicles are bundled together into or many fibers are bundled together into the fascicles, like we said. Hey, and that makes the grain on a muscle too. So there's the grain like in wood. So if you look at a picture of a skeletal muscle like this one, it's maybe probably kind of hard to see, but this is a muscle called the gastrocnemius. We're going to talk about it later or after break. But if you look at a picture of them like on our muscle charts in the lab, there's only these lines in it. There's grains. Those are the fascicles. Oops. There we go. Okay, so we're good there. Each fascicle is bound by a paramycium. Okay, that's good enough. You don't have to add anything to that. And then here it says the entire muscle, like your biceps or whatever, is bound by a wrapper called the epimycium. Here, guys, tell you what. On tissue type, let's write something here. Let's write this. Cut and paste. Make sure this works. Yeah. Okay. Oops. Connective, dense connective tissue. It's tough. It's like a thin. It looks kind of like wax paper, but if you it's really tough and kind of fibery. It's like a really very thin leather. All right, fascia. Guys, anytime you run into fascia, it's not always associated with muscle, but whether it is or not, it's I got a bold there. That's all right. It's a dense connective tissue sheet. So it's a dense connective tissue sheet. And again, it doesn't have to be associated with muscle, like your kidneys have a fascia, and it's the same thing. It's a dense connective tissue sheath on the outside. But in association with a muscle, or actually, I shouldn't say that. Paste. In associated with muscles, here's what it does. It says it wraps groups of muscles together. And I could mention here, it can wrap other things like your kidney and stuff like that too. But so it wraps not an individual muscle, but it wraps groups of muscles. Like, for example, if you heard of the quadriceps muscles, they're the quads. They're the muscles on the front of your thigh. Like, there's four different muscles there, and they've all got the common job of extending the knee. So they've all got a wrapper around them that I'll show you to you guys on the cadaver when we get back and get those out. But yeah, it wraps the whole group of muscles. All right, down here on this, we're just going to fudge this. This note on skeletal muscle, nerve, and blood supply. They got lots of both. Lots of both. Write that down. We're done with that. All right, skeletal muscle attachment to bone. Recap, origin, and insertion. If you guys don't remember what these terms means, definitely write this down. Remember, the origin is the immovable attachment point. So the origin is the immovable attachment point. It don't move. The insertion is the movable attachment point. It does move. It's like, remember for the biceps, brachii, remember it flexes your elbow, bends your elbow. So it attaches it to your place, the shoulder blade, the scapula. That doesn't move when you flex your arm, so that's the origin. It's the radius that does move. It moves up towards the humerus when you bend your arm there, bend the elbow. So the radius is the insertion. Okay, so what do we got here? Okay, indirect attachment and direct attachment. With indirect attachment, it says this is a tendon. So there's something between the muscle and the bone, so it indirectly attaches. Here it says note tendons of the epimycium. One thing to write there is this. Tendons are a continuation of the epimycium. Here, we're kind of short on time, guys, so I'm going to go quick here. Remember, you can pause this whenever you want. So, for an example of indirect attachment, it says insertion of gastrocnemius, which is your calf muscle, on the calcaneus. And we have something called the calcaneal tendon there, which if you haven't heard of that, you probably heard of the Achilles tendon before. So here it says, oops. Okay, so that uses the, so it says calcaneal tendon, which is, you've heard of the Achilles tendon before. It's also called the calcaneal tendon because it plugs into the calcaneus. So, and down here, guys, on direct attachment, it says no tendon, however, I'm going to pause, and then write that epimycium is fused to periosteum. Your muscle wrapper is fused to your bone wrapper, so they're still attached pretty good. So we got seconds left, or I got to stop this video, but here's showing the gastrocnemius, your calf muscle, and here you can see the Achilles tendon going down and then plugging into the calcaneus there. Oh, hey guys, Kate this and move it like this. So epimycium is fused to periosteum, that went up here, and then for example it says gastrocnemius, out of time, sorry.